Hey guys, and welcome to the next lesson on kinetic energy. So last lesson we spoke about what kinetic energy was, briefly, and today we're going to build on those points. The objectives of today's lesson are to gain an understanding as how kinetic energy is identified and how it's used, and being able to calculate kinetic energy of moving objects. So kinetic energy is the energy of motion or movement. So for example, anytime this cyclist is moving along this track, from the start here up to the top of the hill, they're in motion. So they are said to have kinetic energy because they're moving. Again, when they're moving down the hill, they have kinetic energy because they're in motion. When they're at the top of the hill and they are stationary, when they are not moving at the top of the hill, they have no kinetic energy. Just as if they were starting at this point here and they were not moving, they would have no kinetic energy. So kinetic energy is given by a formula written here. EK, or kinetic energy, is equal to 1/2 or 0.5 times the mass of the object in kilograms times its velocity, v, squared. Velocity is in meters per second. So an example of how to use this is in the next slide. So for example, we have an object, a car, a bicycle, something, anything that's moving. And it's moving at a velocity of 10 meters per second with a mass of 400 kilograms. To calculate its kinetic energy, all we need to do is we need to put the values into the formula. So kinetic energy, or EK, which is in joules, is what we're finding out. And to do that, we need to multiply the mass of the object, which is 400 kilograms, which is in the correct units for this equation. 400 kilograms times the velocity squared. So we have 0.5 times 400 times 10. So breaking this down, 0.5 or 1/2 times 400 is 200, and then 200 times 10 is 2000. So the answer of the kinetic energy in this equation here is 2000 joules. We either write the whole word joules out, or we write a capital J. We need to write a unit here. If we don't have a unit, we don't know what we're measuring. It could be 2000 kilometers, 2000 meters, but we need to write the correct unit, which is joules. That's why I'm making this point here. Another example of how kinetic energy formula may be used to calculate the amount of energy in a moving object is this question here, or this example. If a car is moving at a velocity of 35 meters per second and has a mass of 250 grams, what would its kinetic energy be? Remember, kinetic energy, EK, is in joules, mass is in kilograms, so be careful that your units are the same as what is required for the equation, and V is for velocity, which is in meters per second. So to do this question, we first of all need to identify that the units of its mass is in grams. We need it in kilograms because that's what the mass is reported in for this equation. So 1,000 grams is equal to 1 kilogram. So if we just divide the grams by 1,000, we will get the answer in kilograms. So 250 grams divided by 1,000 is 0.25 kilos. And now we have the correct unit for its mass. We put that into the equation, we multiply it by 0.5, and then we multiply it by its velocity squared. So 1/2 times 0.25 is 0.125, and then multiply that by 35 squared, which will give you 153.125 joules, the capital J. These are the key ideas for this lesson. Kinetic energy is the energy of movement. So anything which is moving has kinetic energy. Kinetic energy can be calculated from the formula, which is 0.5 times its mass in kilograms times its velocity. Remember, it's squared. And velocity is equal to its distance in meters over time in seconds. These are the terms for today's lesson, and these are the questions I'd like you to complete before coming into next class. So describing kinetic energy with an example, not the example I've used in this slide. Calculate kinetic energy of the following, and the examples in these presentations should help you work through this. Remember to use the correct units as in the equation. Thanks for watching.